Iowa devices and motor control. Chapter 4. Idea of this chapter is so we can identify electrical symbols for various push buttons and switches, describe the operation and proximity, Hall effect, radar, LiDAR, and ultrasonic. You guys know what radar and LiDAR are? Those are actually acronyms. Radar is radio detecting and ranging, and LiDAR is light detecting and ranging. Radar uses radio waves and LiDAR uses lasers. It's all based on time of flight. Explain how cameras can be used for quality assurance. Explain the difference between passive and active triangulation systems. Bless you. Describe the types of temperature sensors used in industrial settings and common indicators used in PLCs. Explain the purpose of using indicators in PLCs and explain the difference between power relay and control relays. Anybody have any idea about what a difference is between power relay and control relay? Yeah, it has a lot more to do with the amount of current that they carry, though. Yeah, control relay is generally low voltage, low current. Power relay is high voltage, high current. Or it can be low voltage, high current. It's just more about the current than it is voltage, really. I'm going to describe the operation of relay, describe the operation of a solenoid, name two major types of motor control devices, and name two types of overload relays. Push buttons and switches, also called discrete input devices. Many different kinds. You got push buttons, you've got mushroom, flush, extended, guarded, a whole bunch of them. Switches, there's about a bazillion of them up there. Proximity, Hall effect, which operates off magnetism, limit switch, roller lever, a whole bunch of them. They're independent devices that either allow or disallow electric current flow through them. Can be physically changed to an on or off position. It remains in that condition until the state is changed. Sometimes changing the state is as easy as taking your finger back off of it. If it is a spring, regular push button, as soon as you let go of it, it changes states again. Push buttons and switches, like all devices on a schematic, are drawn in their de-energized position unless otherwise noted. Normally open, always open until they're forced to close. The normally open switch, a normally open switch held closed. And then the bottom one is normally open push button held closed. You guys want to set those trainers down so that they're not in the way you can see better. That's a normally open push button. Normally open in that the actuator is above contacts. And then you have that's normally open, held, closed. The actuator is in contact with contacts, but it is still above.
So the bottom is normally open.
Normally open, held, and closed.
Held.
Yeah. Normally closed, the actuator is below the contacts and they're in contact with it. And then that's normally closed, held, open. Poles and switches. The number of poles tells you how many individual conductors the switch is going to open and close. A single pole switch is going to switch a wire. Double pole switch is capable of switching 2 wires. 3 pole, 3 wires, and so on. The number of throws is how many directions can the contacts make or close. So a double throw can either be on or on. So that is a single pole, because I'm only switching 1 wire right here. But it's a double throw because it can either connect this way or that way. Yeah, see that? Then switches, single break and double break. This is a single break because it's only breaking the conductor in one place. This is double break. This is breaking it here and here.
Maybe pointed that way.
Hmm?
You get your camera maybe pointed that way, so this would.
Oh. I told her to look at her own board, sorry.
Yeah, on camera shines.
I wish I did.
That better?
Yes, sir.
Those are actually backwards. One is on this side and it goes to that board. 3 is on that side and it points at this board, so. Okay. Sorry about that. Single and double. Single pole, single throw, single break. Wow, they're calling that a single break also. Okay. I wouldn't say that, but all right. Okay, momentary push buttons, also called spring loaded. Nobody calls them spring loaded. It's a momentary. Locked position. Nobody calls them locked position. Nobody calls them latch. They're maintained. The stop on these trainers over here are maintained, push it stays in until we release it. These guys are momentary, as soon as you let go of it, it lets go, it returns. Manual switch requires an operator to change their state. Automatic is controlled by a mechanical or electrical device. You do not have to turn automatic switches on or off manually. Generally speaking, that would be a limit switch. Proximity, all effect, that sort of thing. Designed to work in harsh environments. Okay. Industrial switches, they're talking specifically about industrial switches when they say they're designed to work in harsh environments.
The ones that are like slipping, like press over the buttons and stuff like that.
Those are for really harsh environments.
Wet environments. Down.
Industrial switches may be exposed to extreme humidity, splashing liquid, gas, or liquid immersion, dust, vibration, high electrical noise. Electronic switches are susceptible to high electrical noise. Rock switches all affect those kind of things. Regular push button or limit switch wouldn't be. Temperature designed to detect a specific preset temperature. From the open closes and from the closed opens. Says 4 temperatures above a set point. That is not necessarily true. Think about your thermostat at home. The contact closes whenever the temperature falls below the set point to turn the furnace on.
Some switches and strong. Right.
Depends on the design of the switch. Generally speaking, a switch that's going to be controlling climate control is normally open, and changing temperature forces it to close. Some of them use vapor pressure technology to sense the change in temperature. Many features and modifications allow them to be used in a variety of applications. Most basic type of temperature switch is just a bimetallic strip. 2 pieces of metal that are physically attached to each other. And they are dissimilar metals. They have a different expansion rate whenever they heat up. So if you imagine they're connected together and one of them heats up faster than the other, they're going to want to kind of bend. Yeah.
You can see those anymore, like they did it. In most school terms, or thermostats at the close them, and then as they expand, they get hot.
Yeah, most of them are electronic now.
Yeah.
Pressure switches used to detect high and low pressure in hydraulic and pneumatic systems. Liquid level, chemical level, or water. Typically placed at specific height in the tank or well. Normally open, liquid level switch closes, and normally closed opens. Above set point there again. Depends on what you're trying to measure. If you want to know when a tank is empty, then switch is going to close whenever it falls below a specific level. Limit switches are physically touched by the part. So you guys sitting on this room or this side of the room, gray switch down here in the bottom is limit switch, roller level, roller lever limit switch. Open or close when an object hits their actuator. Of course, open closes and closed opens. Consists of an actuator that is mechanically linked to a set of contacts used in a variety of applications for detecting the presence of parts, or the air cylinder has extended to a certain point, or the index table is in a certain position, that sort of thing. Flow switches are set to detect specific flow rates. Pipes, heating, ventilation. They can also detect liquid flow in a pipe, that sort of thing too. Float switches. Oh, that's a level switch, wasn't it? Yeah. Float opens and closes contacts in response to change the liquid level. Most of your liquid level switches are float. Put switches used as emergency or contact switches. They're placed in factory environments which workers are using both hands. Sometimes they are for dead man purposes where you have to stand on it to make the thing work. Or if you're holding a part in a machine, you trip it with your foot to make the machine do its thing. That's only done if there's sufficient guarding or other means to keep you from getting in the machine whenever you step on the pedal. Sensors that changes in the environment. They can emulate 5 human senses or goes into electronic signals. Sight, hearing, touch, taste, and smell. Sight does light, size, shape, distance, color, with photoelectric, laser, infrared, TV cameras. They do have electronic sensors now that are capable of detecting color. They're pretty cool. Hearing, loudness, high and low tone, vibration, such as microphone, sonic level, wave level, touch, temperature, pressure, humidity, contact, taste, sweet, sour, bitter, temperature, salty, sugar level measurer, and temperature sensors. Anybody know what a sugar level measurer is called? No.
Sugar level measurer.
Yes.
I didn't know.
No, it's a Brix meter, BRIX. Concentration of sugar in a liquid. And then smell, gas presence. They have gas detectors that are capable of detecting just about any kind of gas you want to, whether it's propane, isopropyl alcohol, gasoline, ammonia, sodium hydroxide. Prox sensor. Proximity can detect the existence of an object. Then what they do is in their name, proximity. That means get close. A lot of people think you have to touch a prox switch to make it work. This is not the case. They work on either capacitance or inductance, depending upon what you're trying to do with them. If you want to do metallic objects, it's an inductive sensor. If you want to do plastics and that sort of thing, you use capacitance, or the other option is to do photo, with, LED. There you got several different kinds. Diffuse, retroreflective, laser. Light emitting diode transmits a infrared light beam. Some of them are infrared, some of them are visible. Phototransistor then receives the presence of the beam, which is triggered when the beam is interrupted by objects placed in the light beam path. Inductive sensors. Detect the presence of nearby metallic objects by measuring changes in magnetic fields. The inductive sensor generates a magnetic field at a specific intensity, and then you get a metallic object close to it. It changes the shape and therefore the intensity of the magnetic field. It can detect that. Capacitive sensors are basically the same way, only it's done with capacitance instead of inductance. Capacitance is inversely proportional to the distance between the plates. You're going to want to remember that formula. Optical sensors can use visible, ultraviolet, infrared, or laser. Require an emitter to generate the light beam and a detector to detect the light beam. Sophisticated modern versions can detect the type of object. I've never personally seen one that can detect the type of object, but Hall effect, switch by magnetic field. Hall effect switches are used a lot in air cylinders, hydraulic cylinders. You put a magnetic band around the piston on the cylinder, and then a switch on either end. When the magnet gets close enough to it, it says, "Hey, magnetic field here." The only problem with that is, what if what you're moving becomes physically detached from your cylinder?
Attached to the cylinder itself.
No,
Become a solenoid.
no. If you are you have a cylinder, have a switch on one end, switch on the other. If one is mechanically connected to the end of the cylinder, when the cylinder moves, so does what it is connected to. It moves too. If it becomes disconnected, generally speaking, no. The rod is always longer than the bore or the stroke on the cylinder. But when the cylinder extends, it's going to push the whatever that is out of the way, and when it retracts, it's going to stay there. Right? So putting the switches on the cylinder works as long as your load doesn't become detached. So really that cylinder is not, or the switches are not telling you the position of what you're moving, but the position of the cylinder itself. So depending upon what you're trying to do, you may or may not want to put the switches on the cylinder itself.
That's great for each or energy,
Mhm.
because if that machine just keeps going. Sucks.
Yeah, it's a bad day.
Yeah, it is a bad thing. Actually,
Time of flight, radar, LiDAR, and ultrasonic. Those all move at a specific speed. The radar and LiDAR move at the speed of light. And then ultrasonic is speed of sound, generally calibrated for speed of sound at sea level. So ultrasonics are usually not used for time of flight whenever any real high degree of accuracy is needed. Because as the density of the air changes, so does the speed of sound. Radio detection and ranging, or radar, used to detect metallic objects, most often metallic. Several cycles of high frequency waves are transmitted into the environment, and the reflection is then picked up by a receiver. The speed of high frequency waves is too fast to use radar in factory for object detection. You guys know that's how the microwave oven was invented? You ever heard of an Amana radar range? It's called a radar range because it operates in radio waves.
that can be intense.
No. It's just a cool fact.
That is interesting.
Now, the guy that figured out that radar can be used to cook with happened to have a chocolate bar in his back pocket whenever he's playing with a radar. And the chocolate bar melted in his pocket. And it wasn't because he was too hot.
It is the water molecules.
Yes, that's how microwaves work. The frequency that they run at is the same frequency that water vibrates at you in. You give the water more energy and its temperature goes up. And then by conduction, it makes whatever it's in hot.
So why you want, when you warm it up, it's kind of soggy. Some things. And steamy too.
Yeah.
Yeah, what culture.
Also why you can't brown meat in a microwave. Doesn't get hot enough.
You also,
It's going to get up to 212, water's going to turn into steam. And
there's also a story on how he accidentally froze a pet hamster, but then when he put it in a prototype microwave setup, he thawed it out and it came back out alive.
that's not entirely accurate.
No,
It was a different guy and he thought, hey, they were testing ways of reviving people. And the way they used to do it was they would take hamsters and lab rats and whatnot and inject them with antifreeze. Not the same antifreeze you put in the car, but an anti-freezing agent. Freeze them until they were dead. And then they would put hot paddles and whatnot on them to raise their body temperature back up, reanimate them. And it was so hot that it actually burned them, caused them pain. So guy decided, hey, I wonder if we could use microwaves because that is much more gentle and, you know, not as concentrated heat source. And as it turns out, yes, you can. Unfortunately, it doesn't scale up to human size because you can't get the antifreeze into the human system, all of its cells, fast enough. LiDAR, similar to radar, detects phase shift in light. Uses a very narrow beam to detect smaller objects, and the accuracy of measuring range can be as small as half an inch. Ultrasonic, ultra meaning above, sonic is what the sound you're able to hear, so it produces sound above normal hearing threshold of 16 kilohertz. The ultrasonic sensors produce sound above 16 kilohertz. Human ear can hear between 20 and 20K. So there are some people that can hear the ultrasonic sensors. I'm not one of them. I spent way too many years in noisy environments. They are relatively accurate over short distances, very economical. Time that is needed for the sound to travel to target and reflect back is proportional to the distance of the target. Same thing with any time of flight sensor. Electrostatic ultrasonic. I've never personally seen one of these. Uses capacitance to determine the distance. Short sound wave is transmitted, hit the object longer ranges, wider bandwidth than piezoelectric, and more sensitive to vectors such as humidity. Piezoelectric work by charge displacement, strain on crystal lattices. That's what piezoelectric is. Take a crystal and apply a voltage to it, it'll resonate at a specific frequency, or if you squeeze it, it'll generate a current. Frequency of sound can be up to 1 megahertz. Camera is an object recognition. Moving camera is used to record image of an object, saved to a computer, and a stationary camera can also be used to detect objects on a conveyor. Triangulation systems, got to have 2 cameras, much like your eyeballs, 2 different angles. You can figure out the distance to the object because of what is known as parallax. Slightly different image in each camera, and then the software is used to determine which one, or where it's at. Or a light source. And then the camera measures exactly where the reflection is on its sensor.
To set this up, you'd have to know like the formula for parallax relative to where the camera's at.
The software hopefully is smart enough to already do that. You do have to tell it specifically where the camera and the light source are in relation to each other. Temperature sensors, thermal resistive, also known as an RTD, resistive temperature device, typically made of platinum. Thermoelectric or thermocouples. Thermocouples are really cool. It two dissimilar metals of specific types welded together. They produce a millivolt, say more thousandths of a volt, proportional to their temperature, within a certain range, of course. Yeah. Many fluke meters have the ability to do temperature, and it's actually measured on the millivolt scale. And then it does the math, you know, so many millivolts is X number of degrees. Semiconductor junction devices, diodes, transistors, use either thermoresistive or thermoelectric sensors. I've never seen one personally. Thermoelectric, there you go. Different kinds of metal. They show those as twisted together. You don't necessarily need to do that. You guys ever heard of Viking appliances? Really, really high end
Sounds nice.
appliances that, you know, rich people have. They also have them a lot in commercial environments. They are made right here in the USA, down in Greenwood, Mississippi. And the company that I used to work for before I moved to Springfield, we did a job for them where we made what they called a fire hazard test board. It had just a shade under 1,500 individual thermocouples on it. And I made, installed, and terminated every single one of them. You talk about one boring job. But it was cool when we got it done. I'll see if I can find the pictures and show you guys, like next class or something. Flow meters measure the rate of flow of liquid and gas. Output a variable signal. What's a variable signal?
Signal of variance, a signal of a variable.
It's an analog.
Analog, exactly. For an analog signal varies from the minimum to maximum value. You remember that?
Yes.
Cool.
Second dial, right? Binaries switch. Analog.
Yeah, digital is on and off, and analog is anywhere between a minimum and maximum. Magnetic flow meters are based on Faraday's law of induction. Coriolis mass flow meters, those things are really cool. They're based on the Coriolis force, which is a force that doesn't actually exist.
But it's still named. Wait, so back up. You said it doesn't. Curious. Like, okay, so why they have a name for a flow meter or that's named after this 30% thing?
Well, a Coriolis mass flow meter works on the Coriolis theory,
Here, okay.
but the Coriolis force is a force that does not actually exist. The Earth rotates at the equator. It's roughly 1,000 miles an hour. Okay, so any air that is at the equator that's being dragged along by the Earth's rotation is also going at 1,000 miles an hour. It just relative to space rather than relative to the ground. Otherwise, they would be standing up on the equator. Now, the farther north or south you go on a sphere, the less distance you have to travel. But those winds are still going 1,000 miles an hour. So they appear to overtake the winds that are at the equator. That's Coriolis force. There are lots of YouTube videos that explain, you ought to watch one. It's really cool. Indicators, pilot lights, ammeters, voltmeters, help operators visually inspect operation of output devices. Different colored pilot lights show each stage or operating condition of an output device. Most often you have red, amber or yellow, green, blue, and clear. And each one of those means something different.
Yes.
Do it.
Huh?
Thinking out loud? Okay.
I'm thinking pilot light, I mean, the first thing I think of is like your furnace or
Well,
that's pilot light, yeah.
these are pilot lights. Also known as a panel indicator. Okay, relays. Does anybody understand how a relay actually works? Want to explain it?
Just the, yeah. It's an electromagnetic field that plunges down the plunger and then makes contact.
That's a very crude operator version of it, but yeah, basically. You have a coil of wire. Whenever you apply an electric current to it, generates magnetic field. Magnetic field attracts contacts. They're current carrying. So when you energize the coil, the contacts that are associated with said coil in physical contact with it. If they are normally open, they will close. If they are normally closed, they will open because they change states when you energize the coil. As it shows on there, the coil and the contacts are electrically isolated from each other. They're physically connected, but they're electrically isolated from each other. Contactor is a special kind of relay, uses a relatively small amount of electrical power to control the switching of a large amount of power. These blue guys down here are contactors. They're powered by 24 volts DC, and we're switching up to 208 volts AC with them. Yeah. That is a schematic representation of a contactor. The coil on the contactor is operated off the 24 volt signal on that drawing. And then when it is energized, contacts C1, C2, and C3 close, which provides the three-phase power to your electric motor. Notice that the bold lines on there represent a higher gauge wire, higher amp capacity. So you're using a relatively small current, in this case voltage, to switch high current, high voltage signal, operate the motor. Solid state relays use transistors that can be switched on in the presence of magnetic field. They have no moving parts that wear out, perform well in harsh environments. The only bad thing about a solid state relay is you have to put a load on it in order to make it shut off. Regular relay, whenever you de-energize the coil, a spring pulls the contact back apart. Solid state relay, once you close it, if there's nothing on there to dissipate the energy, it'll just continue to conduct. So you can have voltage present on the output terminal even after the coil is de-energized. Be very careful with them. Solenoid control device that uses electromagnetism to convert electrical energy into mechanical motion, usually in a straight line. Depending on how it is designed, it's either going to push plunger out or pull the plunger in. Movement is used to close a set of electrical contacts, cause movement of mechanical device, or do both at the same time. They use used to open and close a valve to control the flow of liquid or gas. Wish I had a solenoid valve here to show you guys. Motor control devices, motor starter turns motor on and off. Motor protective device protects the motor from low voltage, high temperature, or overload, which is a high current condition. Motor drive, or VFD, controls the velocity, acceleration, and deceleration. There are two ways to control the speed of an electric motor. One is the number of poles that are in the motor, magnetic poles. Those are physically wound into the motor. You cannot change it. The only way is to change the frequency that it operates at. That's what a VFD is. That's why it's called a VFD. It's a variable frequency drive. You're varying the frequency to control speed. And then how fast you change the frequency will determine how long it takes it to accelerate or decelerate. Overload relays, protective devices on the motor starter, placed in series between the contacts in the motor. Used to detect excess motor current, and contact opens when excess current is detected, breaking the motor starter coil circuit and opening the motor starter contactor. So it kills the control signal and the high voltage. Temperature overload or thermal overload, excessive rise in temperature as current passes through it. It has some resistance, which will generate heat. You guys all had electricity one yet? They're also used in most motor control systems. And the magnetic detection over current through the magnetization line current generates. The more current you pass through a wire, the bigger the magnetic field gets. The magnetic field gets too big, it opens up the circuit the same way that thermal does. They do have faster response time because you don't have to wait for it to heat up, but they are more expensive.